Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. And we have talked about this a few times before, but just going to do it a slightly different way. Take a look at some interesting stats about the sun. The sunrise, sunset, length of day, how it changes from month to month, and which of the sunrise and sunset contributes to that change more on a month-to-month basis. So let's go on ahead and get started here. And I'm going to put myself down in the corner, and here we go. Now, I just picked the 22nd of the month. Since today is November 22nd, I figured, okay, let's just go back and take a look at all the 22nds going all the way back to June. And I will take myself out of the picture here so I don't block anything down the road. So, the other thing I have to point out here is that all of these times are standard time, because when you swap from standard to daylight or daylight to standard, then it messes up the calculations in terms of, how many minutes you added to the day or subtracted from the day or whatever. So there has to be a standard. And so when you see the 4:59 a.m. and the 7:34 and you're sitting there thinking to yourself, wait a minute, sun doesn't go down that early in June, you're exactly right. It's 8:34 because we're on daylight saving time. But I have to keep all these times across all the months on a standard basis. So that is why that's the case. So anyways, the amount of daylight on June 22nd, 14 hours and 35 minutes. And so that's a pretty decent amount of light. Then, as we head on toward July 22nd, of course, the days start to get a little shorter. The sunrise is 16 minutes later, and the sunset is 7 minutes earlier. And so we lose overall 23 minutes of daylight, which is not all that terribly significant. Then, as we head toward August, the sunrise is 24 minutes later, the sunset is 31 minutes earlier, and so we have lost 55 minutes of daylight at that point in time. And then September 22nd, just about on the autumnal equinox, the sunrise is 6:02, so we are 23 minutes later there. The sunset's 6:12, which is 44 minutes earlier. So you add all that up, and we've got 12 hours and 10 minutes of daylight, and we've lost an hour and 7 minutes. Now, again, around the equinox, you would think that the daylight and night times would be the same, but we do have an atmosphere, thankfully, and that bends the sun's rays toward us, and so we actually see the sun before it's actually there. And so that gives us an extra 10 minutes of daylight on or about both the vernal equinox and the autumnal equinox. Okay, October 22nd, sunrise is 25 minutes later, and the sunset is 42 minutes earlier. So now we're down to 11 hours and 3 minutes of daylight, and once again, just like the previous month, we've lost an hour and 7 minutes. Then November 22nd, today, the sunrise, 6:57, so that's 30 minutes later. The sunset is 26 minutes earlier, and so now we're down to 10 hours and 7 minutes of daylight, and we have lost another 56 minutes. Okay, here's where it gets interesting. December 22nd, on or about the winter solstice. The sunrise, that trend really doesn't change. That's 24 minutes later. And so you look at all those changes, 16, 24, 23, 25, 30, 24. They're all in the same general ballpark. But look at the sunset. Now, instead of being much earlier, the way it was in all the prior months, at least from August on, it actually gets later by 1 minute. The earliest sunset actually occurs in early December, and it's already starting to get a little bit later by the time we get to the winter solstice. So the reduction in the amount of daylight by 23 minutes on December 22nd is due entirely to the sunrise being 24 minutes later, okay? And then, to make it even stranger, let's go on to January 22nd here. The sunrise is exactly the same. The sun comes up at exactly the same time, even though it's a month later, but the sunset is 26 minutes later. So in January, the increase in the length of the day is due entirely to the sunset being later. And one of the reasons for this is the fact that our orbit around the sun is not circular, it's elliptical. And so when we are closer to the sun, we are moving faster, and when we're farther away, we're moving slower. And here's another weird tidbit, which a lot of people find hard to believe. We are closer to the sun in January than we are in July by about 3 million miles, okay? but it is the angle at which the sun's radiation hits the Earth that determines how hot or cold we are. That 3 million miles difference in distance really doesn't have much of an effect at all, very, very small effect. But it's the angle, how high up in the sky the sun is, that dictates whether or not we are in summer or winter or in between. So when we are moving faster, when we're closest to the sun in January, and slower when we're farthest away in July, that means that the sun and the Earth's time system is not as constant as we make it out to be with our time system, okay? And so that makes these changes in the sunrise and sunset not symmetrical. In other words, let me put myself back in here. I know I always assumed that, there we go. I always assumed that the sunrise and sunset sort of converged to the shortest day of the year, and then after that, they just symmetrically moved apart again. Well, that's not the case at all. One is getting, staying the same from December to January, and the other one is getting much later. And so the days are, getting longer. And in December, the shortening of the day is due entirely to the sunrise being later, and really no appreciable change in the sunset. So anyway, I thought you might find that interesting, that life is not quite as simple as we make it out to be, and this is only one of many examples of that. All right, folks, again, have a wonderful Thanksgiving, and we will be back with you again with another bonus weather video on Friday, and the next daily weather update will be on Friday as well. So you all take care, folks, and we'll talk to you soon. See you later.